Alright, so welcome to our next skill. We're talking about multiplying fractions, and this is helpful for a number of reasons. There are a few things we do in 6th grade that requires multiplying fractions, multiplying mixed numbers, and a little bit of review is always helpful. So again, when we talk about multiplying fractions, we know that we do it by multiplying numerator by numerator and denominator by denominator, and simplifying from there. We're not cross-multiplying at any point. We're multiplying straight across, numerator to numerator, denominator to denominator. Because a lot of us get confused at this point, and we start doing things like multiplying numerator by denominator and any combination of things. All we do, multiply straight across when you multiply fractions. So let's do it. 2 times 4 gives us, you got it, 8. We've multiplied numerator by numerator. Multiplied denominator by denominator. 3 times 8 gives us, if you guessed or knew, 24. You are 100% correct. So when we multiplied 2/3 by 4/8, we got 8/24. Now you ask yourself, can I simplify this at all? Absolutely. Ask yourself, what is that greatest common factor between both 8 and 24? What can I factor out of both of those numbers? I can factor 8. I'm going to divide my numerator by 8, and I'm going to divide my denominator by 8. Now I do my division. What is 8 divided by 8? And that is 1. And 24 divided by 8 is going to give us, what do we think? 24 divided by 8 is 3. Here's my final answer, 1/3. So now that we've practiced multiplying regular fractions, let's look at something that's a little more complicated. And I think this is where a lot of us get hung up. We see this mixed fraction or mixed number, and we suddenly don't know how to do the multiplication. We can't just multiply straight across, numerator by numerator, denominator by denominator, because what about this whole number right here? This is what we need to do. When we see these whole numbers, we see these mixed numbers, we need to turn this mixed number into an improper fraction. And if you remember, an improper fraction is a fraction whose numerator is greater than its denominator. How do we do that? We multiply the denominator by the whole number, and to that product we add the numerator. This would be 2 times 2 plus 1. Well, what's 2 times 2? You got it, 4. Plus 1, we get 5. Our new numerator is 5. And our denominator remains 2. Your denominator will never change. Now, bring down the rest of your problem. Times 1/5 equals. So now this looks more familiar. What do? I multiply straight across. 5 times 1 gives me 5. 2 times 5 gives me 10. Can I simplify 5/10? What is the greatest common factor between 5 and 10? What can I divide both of these by? I can divide them both by 5. You got it. And 5 divided by 5 gives me 1. And 10 divided by 5 gives me 2. So here we have it. When I multiplied 2 and 1/2 by 1/5, I ended up with 1/2. Easy as that. All right, so we've practiced the basics of multiplying fractions and multiplying mixed numbers. So let's put it into context. We're given this shoebox, okay? The first thing we should do when we're presented with a situation is look at what we were given. Look at the diagrams. Explore the art in the problem itself. So it's a shoebox. We know it's a shoebox because it's got a Nike symbol, and it's a rectangular prism, and we're given a bunch of different measurements, okay? So this is the first thing we should see. What am I given? I'm given a shoebox. I'm given some of its measurements, and I know that it's a rectangular prism. Let's go to the question. What is the volume in cubic feet of this shoebox? So here it tells us a few things. What is the volume? I'm looking for volume in cubic feet, because when we find volume, we're talking about cubic measurements of this shoebox. So we should be thinking volume, box, rectangular prism. Oh, there's a formula for that. What's the formula? Volume equals length times width times height. So now that I've analyzed what I have, what I'm given, I ask myself, what is the rule? Well, the rule is for volume, I multiply my length by my width by my height. And this is going back to 5th grade, but we're stepping it up a little bit with the fractions and some of these more complex numbers. So what am I going to do? I want to find the volume. Here's my rule. Let's do some substitution. Am I given the length? Yes, I am. The length is 1 1/5 feet. Am I given the width? The width is going to be 5/7 feet. And my height, 5/8 feet. So let's plug that into my formula. My length is 1 1/5. 1 1/5. And I'm going to multiply that by my width, which is 5/7. And I'm going to multiply that by the height, which is 5/8. So what changed here is that we have more numbers to work with. What I would suggest we do is tackle this piece by piece. Piece by piece. And what I'm going to do first is I'm going to multiply these first two fractions together. It doesn't matter what order I multiply in, but I like to go from left to right. Sometimes it's helpful just to do this in a linear way. So let's do 1/5 times 5/7. So I'm given this mixed number. I know that I have to turn it into an improper fraction. So what do? Multiply the denominator by the whole number and then add that numerator. 5 times 1 is 5, plus 1 is 6. My new numerator is 6. My denominator remains 5. 5/7. I don't have to change anything here. 5/7. Now I'm going to do that math right now. What is 6 times 5? 30. What is 5 times 7? 35. I'm left with 30 over 35. Can I simplify this at all? Certainly. What can I divide both 30 and 35 by? What's the greatest common factor? It's going to be 5. Divide each by 5. I end up with 30 divided by 5 gives me 6. 35 divided by 5 gives me, you got it, 7. So I have 6/7. The product of these two fractions is 6/7. So now I've taken care of this and this. I'm going to substitute the rest. I'm going to substitute that height in down here. 6/7 times 5/8. Now, I don't have any mixed numbers. I can multiply straight across. I don't have to do anything. 6 times 5 again is 30. And 7 times 8 gives us, you got it, 56. Now, can I simplify my answer? Well, the answer is yes. Now, by what? What is the greatest common factor? Sometimes with these larger numbers, we're not really sure what the GCF is, and for the sake of finding an answer, sometimes we have to do a little bit of guess and check. So I know that both of these numbers are even. It ends in a 0, it ends in a 6, and all even numbers can be divided by, you got it, 2. So I'm going to divide the numerator and denominator by 2, which is going to give me 30 divided by 2 is 15, and 56 divided by 2 is 28. Look at this number, 15 over 28. Are there any common factors here? Can I divide both 15 and 28 by any common factor? The answer is no. So right here, we have our final answer, 15 over 28. So again, bringing this back to the problem itself, we wanted to know what the volume of this shoebox was. It was 15 28ths feet cubed, and we represent cubed as being raised to the third power. The third power because there are 3 dimensions. There is a length, there is a width, and there is a height. Here's our answer.